So let's continue with this topic, degree of unsaturation or index of hydrogen deficiency. Now, in the previous videos, you have seen how we determine these values from a structure, in fact, a skeleton structure, very quickly. So what if that molecule has other elements such as nitrogen, halogens, fluorine, chlorine, bromine, iodine, oxygen, sulfur? What do? Is there any change in terms of the formula? Let's analyze. There are 3 carbons here with oxygen, and the formula is C3H7OH. If you use the formula and calculate, there are 8 hydrogens here, and you subtract it from the theoretical number of hydrogen that 3 carbon would make of C3H8 alkane. Recall? You get 0. So there are 0 degrees of unsaturation if you look at this molecule that has no pi bond and no ring. 0 degrees. What this tells you is that oxygen, it doesn't matter to your calculation. Just ignore it. Same thing for sulfur. If I give you an ethane thiol, C2H5SH, all right? Okay. When you try to calculate the degree of unsaturation based on the formula, you will take 6. These 6 come from, if I get a C2H6 alkane, right? Subtract with the number of hydrogen we have over 2, again I get 0. And you look at this formula, there are 0 rings and no pi bond. So indeed it is 0, which means for oxygen, sulfur, you don't do anything, just ignore it. For halogens, as I mentioned just now, a halogen substitutes a hydrogen undergoing a free radical substitution, which means that you treat halogen, let's call X, the same as hydrogen. So if you look at this example here, a branch alkyl halide, 1, 2, 3, 4, again 4 carbons, and 0 degrees of unsaturation, I will quickly put down C4H9Cl, and that's a formula. And why? Because I could subsume this chlorine, which is a halogen, into a hydrogen. So to me, when I'm seeing this molecule, I'm thinking of a C4H10 kind of degrees of unsaturation, which is 0 degrees. And indeed, in the structure, there are no pi bond and no ring. Let's give it a try for a bromobenzene. Okay, a bromobenzene. The formula is C6H5Br. 1 ring and 3 pi bonds. So in total we have 4 degrees. And we subsume this bromine into hydrogen. Effectively we are having a C6H6. So looking at the formula for the alkane with 6 carbon, a hexane, this gives us 14. 14 minus what we really have now, which is 6, divided by 2. Indeed, we have 4. 1 ring plus 1, 2, 3. 3 pi bonds give you 4 degrees of unsaturation. Now for the last example, we talk about nitrogen. Let's say we have C2H5NH2, right? If you join them together, you have a C2H7 nitrogen, right? Like this. Then it's very puzzling. If I look at the carbon only, the formula I could get from an alkane would be C2H6. It is not enough to subtract. And as we draw this molecule out, this looks like that, all right? No pi bond and no ring. That means one look at this, we know that it has 0 degrees of unsaturation, which means that whenever you see nitrogen in the formula, you will subtract a hydrogen potentially from your molecule. Basically, to do calculations, this to me appears as a C2H6 formula. So if you take the alkane that has 2 carbon and subtract the hydrogen from there, you get 0. So indeed, 0 degrees of unsaturation.